We're going to go ahead and get started. First off, what we're going to be doing is we're going to an introduction to sound, and what we're going to talk about is the physics of sound, how sound works, and how you can get the best sound out of your model with the speakers that we've got. Couple of house cleaning things. First off, for those of you who don't know me, my name is George Bogatuk. My primary function with the company is in the sales department as a product specialist. And as a model railroader myself since I was 14, I've got many years of experience that I can draw from to try to help explain the way things are operating and how you can get the best out of your decoders. First off, sound is addicting. If any of you guys have your first sound locomotive and you put it on the track, after a while, if you look at it and realize that suddenly is the only locomotive you're running all the time. And so then it becomes you need to add that extra locomotive, and you get more of them with sound, because I like this locomotive, but I'm always running that one because it's got sound. So it is very addicting. The other thing is sound adds the extra fourth dimension, and we build our models, we've got our scenes, we've got such a great visual experience of what we're doing, but once we add the sound into it, it adds that extra element of experience, and because we're able to experience that sound coming out of those models. And so it does make it a lot more fun. And then adding sound is not as difficult as it looks. We're going to discuss a lot of different cases here as we go through, but the other thing is the extra effort that it takes to put in sound is a lot better than hiding over in the corner when you're running your train going chum 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 chum. Woo! So we want to make sure it's a lot more fun, and so therefore we're going to show you a lot of things here today. So first up here, we're going to look at the different types of sound systems. First one you have is a stationary and an onboard. And let's look at each of these different types of options. So a stationary sound system would be our SoundTraxx product. And this is a product that sits on the shelf and is wired to speakers that are stationary. And the sound is transmitted from that SoundTraxx unit to surrounding speakers on the layout. This will reproduce a lot of the sounds that you're looking for, but it is stationary. The other option is an onboard system, and that's primarily what the SoundTraxx Tsunami2 is used for, is onboard sound system. And so you can see a picture there where you've got the decoder and the speaker in the tender, and then you have the motor and the lights and your track pickup on your locomotive and tender. So this is kind of an example of a onboard sound system. Anyway, when we get into the physics of sound, this is one of the biggest things that a lot of people don't know or don't understand or have not been exposed to. There's a couple of aspects of sound, and first one is volume, and that's how loud something is. And typically that's the pressure or the amount of how strong that air pressure wave is that's going. First off, sound is coming from a speaker. It's air pressure waves transmitted through the air that our ears interpret, and that's why we have the eardrum. It's interpreting those air pressure waves and determining that it is a sound that we're able to interpret, and our brain turns it into a sound. Volume is the air pressure and how high pressure that air pressure wave is, and then the frequency of those air waves is determining the different sounds that we're hearing. And so when the speaker is working, it's creating air pressure waves that are transmitted through the air our ears are interpreting. And so if you look at the diagram there, you can see, for example, the two lower squiggly lines there, they're the same frequency, and the frequency is the amount of space in between each air pressure wave. And you see that they're the same, but you see that the top one is a little higher or higher pressure than what the lower one is, and so that above wave there is going to be a little stronger and louder than what it is. Now, one of the biggest things, and we'll get into the discussion here, is how you can adjust volume and frequency based on your speaker choices and how it's installed in the model. But when we look at frequency, we want to look at the ranges of sound, and this is when you get into the hertz. Hertz is a unit of measurement for air pressure waves traveling through the air. And when you look at the low frequencies, then that's typically the bass. And you're going to hear diesel engine exhaust, steam exhaust chuffs, firebox blowers, and there's usually some notes on the horns and whistles that are down in that low frequency, and that's 20 hertz to 500 hertz. Now, if you look at that, you're going to see a lot of pretty important stuff down there. And we're going to discuss a little bit of that in detail on the different frequency ranges. But when we get into the mid-range, you start hearing a lot more of the horns and whistles. This is where you hear things like air pumps, radiator fans, things like that. And so that's between 500 hertz and 2500 hertz, I'm sorry. And then when you get up into the treble or the high frequency, you're going to hear things like bells, dynamos, and turbochargers, and those are those really high frequency sounds that you're hearing coming out of your models. Now, if we look at a 3-chime whistle here of a K28 Mikado, this is what it would look like in the spectrum analysis in our lab, in the sound lab here that we have. And so you can kind of see how some of the lower frequencies are still there, but you see a lot of the high frequencies. And so this is what our engineers have to look at when they're looking at cutting the raw audio files and creating a actual audio file that we can put into the decoder. And so they're taking those sound spectrums and turning it into audio files that we can use in our decoders. So when we look at the air pressure waves that are being created by a speaker, the speaker cone, when you take the speaker and you look at it, it's basically transmitting air pressure waves by moving the diaphragm back and forth, and those air pressure waves are what are then sent out into the world. But when your speaker starts to move in the forward direction, it creates a sound or air pressure wave on the front of the speaker that then travels out. But the problem is when the speaker moves forward, on the back side here, it's also creating a negative air pressure wave. And so what happens is when all of this is open to the same air, these are 180 degrees out of phase. So if this is open to the same air, what will happen is that the sound will cancel itself out, and therefore you get low quality sound. So when your speaker's moving back and forth, the air pressure is traveling away from the speaker. So here in front of me I have a 3-inch speaker. And what we're going to do is we're just going to go ahead and play some sound, and just so you can see what we're looking at, this is the speaker right here. And right now there's no baffle on it. So we're going to go ahead and move speed step 10. Blow the whistle. And you can kind of hear the sound, but you're also noticing that you're not really hearing a lot of those low frequency sounds. So to make sure you guys can hear this, I'm going to move this microphone a little closer. Now I'm just going to take a simple Tupperware that we've got that actually matches the diameter of this speaker. So I'm going to take this speaker here now, and I'm just going to simply put this baffle over the speaker. And you can now hear how much richer that sound is. Now let's blow the whistle. It's quite a drastic difference. And so this is what you're doing when you're putting a baffle on there, is you're isolating the front and back air pressure waves to make sure that the sound is traveling away from the speaker and not canceling itself out. So we'll do this again. So here's the whistle. And then we'll put the baffle over and blow the whistle. So you can definitely hear how much difference the baffle makes when it comes to putting a baffle on your speaker. So the next baffle we've got here is just a simple box. And this is a simple enclosure that you're going to mount on there that's very similar to the Tupperware here that I'm using on the speaker. It's just a simple box that you put in. Now, the benefits here are that it's easy to adapt to model trains, and it's easy to build because you're simply building a box with an opening in it. So here's an illustration of what a simple speaker would look like with it. Now, if you look at that, many of you can see how a tender, for example, would be a simple acoustic sealed box, because you put trucks underneath that box and run it on the track, and you put a coal load over the speaker opening, you got yourself a tender and a nice baffle. Now the next type is what's called a vented port speaker. Now what this does is this helps improve the efficiency of the speaker, because as I mentioned, it takes the negative air pressure wave on the back of the speaker and the positive air pressure wave on the front. Well, what these typically do is they're designed specifically to enhance that long travel for the air pressure, so that when it comes out of that vented port, it's actually in tune with the front of the speaker, so that way now those air pressures coming out will help give you a much better sound volume. Now, the problem is that when we're talking about speakers that we're going to find in our model trains, you're going to hear minor differences, but it's not going to be a drastic difference. And so by the time you spend designing this to get the right frequency and the right length for it, you're not going to hear that much difference, because when you're talking about speakers that are really small coming out of there, a vented port speaker is usually not going to give you a whole lot. When it comes to getting quality sound, there's 4 critical factors that you're going to want. First of all, as we've illustrated here, proper baffling. Now, the other thing you're going to want to look at is speaker type, the speaker size, and the speaker quality. And these are all things that we're going to cover here in just a second. Basically, don't do this. This is something that we've seen over and over. We'll get people say, I can't get quality sound, and we'll ask them to send a picture of what they're getting, and this is something that we've seen quite a bit. And so that's part of what this presentation is all about, is to show you the different types of baffles, how to do it, and what you want to do. But this happens a lot more frequently than you would expect. Now, when it comes to speaker baffle materials, there's a lot of things that you can use. You can see some things in that illustration, such as pill bottles, tape rolls, plastic, styrene, things like that. And so I've got some examples here on the table of some simple things that we can use to show different types of baffles. And so, for example, here, this is a paper towel roll that has been a piece of cardboard glued on the inside of it and creates a baffle. And so when you put that over your speaker, you're going to get the baffle that you're looking for. Other things that I have here, this is a PVC pipe cap that we just drilled out a couple of holes. You can mount a speaker into it. And I do realize these are fairly large pieces of example. But here in this case, I've got a soda cap. That's just a soda cap off of a Coca-Cola bottle that I took our 28 millimeter round speaker, and you can fit right in. Biggest thing about using this is make sure that you wash it and get all of the soda residue out of the cap, because once that soda residue gets onto the speaker, you're going to ruin the speaker. And then you can drill a couple of small holes on the back side of it for the wires to come in. But it's just a perfect fit, and you can just snap it right in or put some silicone on and hold it in place. So you can find all kinds of good baffles. This is using our Mega Bass speaker, where we've taken a 1/2 inch wide strip of styrene sheet that had been cut and glued to each of the 4 sides of the speaker, and then we take another piece of the sheet and glue it to the top. A simple, easy to make baffle. And the baffle design doesn't have to be perfectly exact. When you're building a speaker baffle, you want about a 1:1:1 ratio. The numbers are actually a little different, but it comes out, as far as volume is concerned, volume is concerned, about a 1:1:1 ratio. So you've got different examples here of what you can do. These Mega Bass speakers, for example, don't easily fit into an HO narrow hood diesel. So what you can do is you can take this speaker and mount it at an angle and build you a custom baffle that would fit inside that hood housing, so that way this speaker can fit in there. Your housing doesn't have to be square like every time like this. So if you build it to fit inside the house, inside that narrow hood diesel with an angled baffle and a custom built, you can fit this into just about anything that you're looking for. Now, we've also got some examples of some factory installed one. This is one that came out of an HO Athearn Genesis 484 a few years ago that was just simply in there, but it's 2 speakers wired in series, and we'll come back to that example here in just a minute. So these are some of the other examples that we've shown you here in front. Now, there are some other examples, as we do have some commercial baffles that we do have available. This is an example here of our 28 millimeter round speaker baffle, or the 1-inch speaker baffle that you can buy from SoundTraxx, part number 810110. And this again fits this 28 millimeter round speaker really easily. It just snaps right in place, and the speaker baffle assembles by snapping everything together. Some other examples we have, and these have become very, very popular over the last several years, are our Minicube speakers. And this is our Minicube 1 and then our Minicube 2, and you can kind of see how the size difference is a little bit different. And the benefits of these are these actually have a lot of low frequency tones available in them. The problem is low frequency is also typically at lower volume, and so what happens is some of the lower tones don't get reproduced as well because they're not traveling. And so what you can do is take multiple of these mini cubes together and put them into your installation. And again, we'll talk about multiple speakers here in just a moment. Now, when we look at the different types of speakers, many of you guys have a surround sound system that you have for your home stereo system, your TV, entertainment center, whatever. And you typically will have a woofer, which is a giant box that has a big giant speaker onto it, and that's designed for the lowest frequencies. Again, when it comes to low frequencies, it has to do with the speaker travel, and the longer the travel, the lower the frequency. And so that's why those speakers tend to be big, because the bigger speaker has a longer travel. And those are the ones that typically will reproduce the low frequencies. The next one you have is what's called a tweeter. And pretty much the tweeter is the one that produce the higher frequency tones. When you start getting up into the mid to high range, that's where the speakers really shine. And by audio standards, most of the speakers that we're using in our models are considered tweeters by audio standards. And so when we start talking about these mega bass, yes, they're able to reproduce some of the low frequencies, but they're still not a woofer type speaker. They're still considered a tweeter type. And so especially like when we talk about our 28 millimeter round or the mini cubes, these are all considered tweeters. They do have a wide frequency range, but they also are able to reproduce those high frequencies better. And that kind of brings me to a point that I want to make, is when typically you install a couple, a speaker or two in your model, and you'll hear the diesel engine exhaust or something like that playing. When you put that in there and then you turn on that bell sounds so much louder than even anything else that you're hearing. And part of the reason for that is because, again, when we're talking about tweeter speakers, that's right in the frequency range of a bell is right in the speaker's hot spot. That's where it's the best and performs the best. And so when that bell sound plays, it comes through a lot more cleanly than, say, some of the other sounds. Now, with the Tsunami2 and our Economy product, we do have the ability to adjust the volume level of all of our sounds individually. So you can go through and take that bell volume and reduce a little bit so that the speaker's not cranking it out, so you can't hear it all the way across the layout. The other thing I wanted to point out is in our Tsunami2 and our Economy product, we do have a 7-band equalizer, just like you would have on your home stereo system. So what this does is this allows you to boost low frequencies, reduce high frequencies, or vice versa. It allows you to get the most out of your speakers so that you can look at your speaker frequency range, which we'll get into in just a second, and you can boost the frequencies so that way the speaker can give you a more even distribution of the sound throughout the spectrum, but you're able to basically maximize the speaker's strengths and minimize its weaknesses. So that way the speaker's not trying to reproduce a frequency range that it can't physically do, and therefore potentially cause distortion for other sound frequencies. Now, one of the other things I wanted to point out is some of our competitors actually will go in and pre-filter a lot of those sounds already and they tune them to a 28 millimeter round speaker. And they tell you that, oh, you don't need an equalizer, we've done the work for you. Well, what I hear is we've already pre-filtered the sound, so even if you had a 3-inch round speaker or anything like that that would be able to reproduce those low frequencies, they've pre-filtered that out for you. SoundTraxx gives you the full spectrum, so you can pick the speaker that matches your model and you can get the sounds that you need out of it. So this next chart here we're going to look at is kind of a spectrum chart of what you're going to see in typically some of our speakers, or some of the speaker types that we just talked about, I'm sorry. So you can see how the orange line, which is a woofer, really is good at the low frequency, but once you get up to the higher frequencies, it drops off dramatically because it's not very good at the high frequencies. But if you look at the purple range there, you can see how it's really, the tweeter there is really bad at the low frequencies, but is really good at the high frequencies. And this is why when you have your surround sound system for your stereo, you have the bass subwoofer that's located down in the room somewhere, and then you have the tweeters mounted around the room. Now, as animals, we're hunters by nature, and so our ears are able to determine locations of high frequency sounds, but not necessarily low frequency. And so that's how a surround sound system works, is by putting the satellite surround sound speakers of tweeters around. The high frequency comes from the surrounding speakers, and the low frequency comes from a single point source in your room where the subwoofer is. Our ears can't detect where the subwoofer is coming from, but they can detect where the high frequencies are, and so it basically fools our ears into thinking all of the sounds are coming from the various places around the room. So when we get into speaker size, bigger is better. And I'll say that in pretty much 90% of the cases, and we'll cover that in just a minute. And part of why is because when you have a bigger speaker, typically that speaker travel is going to be deeper and longer. And that's why you want a bigger speaker, because the bigger cone is also going to produce more volume. So when I take a small speaker like our small mini cube and compare it to, say, our 1.1 inch mega bass speaker, we're going to be able to look at those and say this one's going to be able to produce a lot higher volume than, say, something that's coming out of a very small speaker. And volume, again, is pressure, and so the bigger the cone, the more pressure it's able to reproduce. Now, the other thing you want to look at is the voice coil. And the way a speaker works is by sending electromagnetic pulses through the coil inside the speaker. And inside the speaker, you have the voice coil, and there's a magnet. And as those electrical currents are going through, it's either attracting or repelling from the magnet. And that's what creates the speaker to move the pressure back and forth. And so when you look at the bigger voice coil, typically it's going to have a much stronger presence and power when you get the electromagnetic field going, and so it's able to travel a lot farther. And again, you want to look at the bigger magnet too, and the bigger magnet size is also going to give you a stronger attraction and repel of that power. Now, when you start talking about, the bigger speakers is better, in some cases I'll say that you can use 2 to 4 smaller speakers to help reproduce that as an alternate. So let's go back to our mini cube speaker, for example. These are able to reproduce down to 100 hertz frequency, but because they're so small, it's such a low pressure. When we were doing some testing with these not too long ago, we took a spectrum analyzer, and about 18 inches or so away from the speaker, you couldn't hear anything lower or see anything on the graph lower than 250 hertz. But when you put it right up on it, about right there, you were able to see that it actually is reproducing it, but again, lower frequencies are lower pressure, and so they didn't come through very strongly. So the 2 of these is going to do a much better service for you, and we'll get into multiple speakers here in just a second. And then when you look at our HO narrow hood diesels, things like rectangular or oval speakers are really what you're going to look at as an alternative, because you can typically build a baffle or mount it in your model a little bit easier because it'll be square. You can glue it to the roof line and stuff like that. But we'll get into multiple speakers here in just a minute. So when you're looking at the quality, you want to look at several things, and one of them is the frequency range. And as we were talking about, our mini cube speakers are able to reproduce down to 100 hertz, and some of our oval speakers and our round speakers are able to reproduce very well down to about 200, 250 hertz. And so having multiple of these speakers is going to give you a much better frequency range and a better response. The cone material, a lot of times you'll see bigger speakers typically have a paper cone, whereas some of the smaller ones are going to use a plastic or a mylar type material, and it just has to do with the flexibility and how that speaker works. And so you've got different materials to work with in that. The suspension, which is the type of material that it's held in, so you've got metal frames versus plastic frames. The biggest thing is if you start getting into bigger speakers and you have a small plastic frame, when that cone starts to move, what you don't want is that speaker frame or the suspension to start flexing in addition, and that's where you start looking at those type of things. Some of the other things you want to make sure, and I want to highlight the next two, is the impedance. Our decoders are rated for an 8 ohm load, and that means you typically want one 8 ohm speaker, or you can add multiple speakers, and again we'll get into that in just a minute, where you want to do above 8 ohm or above. So when you're looking at this, if you take 2 4 ohm speakers, put them in series, that's an 8 ohm load, but if you take 2 8 ohm speakers and put them in parallel, that's going to create a 4 ohm load, and so you're going to start overtaxing the amplifier and potentially damage it. So you want to make sure to match the impedance. The other is the power handling, and this is where we start looking at the wattage of a speaker. So for example, our 28 millimeter round speaker that we typically offer is capable of producing up to 2 watts of power. Now, many of our decoders in our Tsunami2 and our Economy product line actually do reproduce 2 watt or have a 2 watt amplifier, and so when you crank those volumes up, it can put 2 watts. If you use a smaller speaker that's not capable of handling it, you run the risk of potentially damaging the voice coil. And then if it ends up open, then you got lucky. But if it ends up as a short, then you're going to short the decoder and the amplifier, and you're going to damage it, and it's going to have to come back. So you want to make sure that when you pick a speaker, you pick one or multiple speakers that are going to be able to dissipate that power that's coming from your decoder. And then, as we talked about, the magnet size. So these are all things that you want to take into factors. Now, when SoundTraxx goes through and picks a speaker to put into our product line, we usually run it through the ringers. We test it, we put it through maximum and minimum tests to make sure that when you put that speaker in, you've got the confidence to know that it's going to work with your decoder. But again, impedance and power handling are things you're going to want to look at when you're picking your speaker. Now, looking again at the frequency chart, this is one of the things we talked about, and so here's a few different frequency ranges of some of our speakers that we have in our product line. And so you can kind of see there how the 1.1 inch mega bass speaker has a really good low to mid range. It kind of fizzles out and then drops down there towards the top of the frequency range, whereas some of the other ones kind of are about in the mid range as well. Now, the 3/4 inch round is a smaller speaker, so you can tell looking at the spectrum graph there that you can see it's at a lower pressure. The bottom of the chart is frequency range, and the side of the chart going up is the pressure. And so you can kind of take a look at that. Now, when we talk about different techniques, now there's simply, you can just hook your speaker up one at a time and connect them, and you're pretty much good to go, as long as you follow the previous things that we've discussed. But when you start looking at different ways using multiple speakers, and we'll talk briefly about a crossover network and subwoofers and stuff like that. So when you're wiring multiple speakers, again, this is where you have to look at the power handling or the impedance of the speaker. And a typical 8 ohm speaker, you're going to want to run 2 of these in series to give a 16 ohm load. Now, you would think 16 ohm loads is more than 8, and so your amplifier is working harder, but it's actually the other way around. When you have a 16 ohm load, the amplifier actually isn't being taxed as much. It's actually working a lot more efficiently, and therefore you're going to get a better sound and better quality, and you're also going to relax the amplifier a little bit, so you're not going to push it. The other alternative there, as I show there, is parallel, and that's where you're going to get the 4 ohm load, and that's basically where the positive wire from the decoder is going to go to both positives on each speaker, and then the negatives for the 2 speakers are going to go back to the negative, rather than doing them in a series in a daisy chain. The one thing I forgot to mention is when you are doing a series, you want to make sure that your plus and minus of the different speakers are matched up, so that way when they work together, they're both moving forward when that power comes through. Because if you have one that's doing this and doing opposite scenarios, then the 2 speakers are actually going to cancel themselves out, kind of the same way we did when we didn't have the baffle on our speaker. So with that, we'll go to the last one there, I'm sorry, I forgot to mention, is the series parallel. And this is where you can take 4 speakers and mount them in your model. And again, this is going to be very popular. We've got an example here showing you with our mini cubes. But you're going to take 2 speakers and wire them up in series. And then you're going to take those pairs and parallel them, so that way, again, it creates an 8 ohm load. So your amplifier is still happy, but now you've got the benefit of those 4 speakers. So now when you've got 4 speakers trying to reproduce those low frequencies down to 100, 150 hertz, you're going to have a much better chance of being able to hear it now, because now those 4 speakers are going to work together to recreate that sound. So now with 4 speakers, you're going to have a much better air pressure of the frequency as it's coming out, so you'll be able to hear it a lot better. So just some kind of examples here. We've got one example of our 1 inch round, which you'll recognize from the chart we previously showed you. But then you can see where multiple speakers there are going to give you a much better response than what you would get if you had one by itself. And mostly you're seeing a higher pressure. So when we go to the next example here, this is a model that we have taken to trade shows before, and you can see where there's 4 Minikube speakers there wired in a series parallel configuration. This particular model is an Intermountain, one of their new Tier 4 GEVOs that they've done recently. And this is where I actually became more of a Minikube speaker convert myself, was once I heard that sound coming through and those low frequencies being able to come through a lot better in that scenario, and they fit, I was sold. And so now I put at least 2 Minikubes in most of my installations. So this is just one example, but you can adapt it to fit into your operations. Now, when you get into crossover networks, and this is something that's going to be a little difficult to do with a HO model or something like that, but you can actually go through and filter the low frequencies to the subwoofer or the bigger speaker. So say, for example, if you have the ability to put something like a 3-inch round or even one of our mega bass speakers in the tender, and then say you only have room for one of our mini cubes up front. Well, what you can do is build a crossover network, and this information will be able to be accessed later. We're not going to go into too much detail, but basically you've got an inductor and you have a capacitor, and those act as filters, and then based on where your frequency ranges are, and this is where you want to look at your frequency range of your speaker, but based on where you want that filter to cut off, that'll give you the values to plug into those equations. Now, again, for more detailed information, you can go online and find all kinds of information on how to build a crossover network. But if you contact us, we'll try to help you as best we can with what you're looking at. But this is just an example of one of the things you can do with your locomotive and with your models. Now, with all of this and this physics of sound and everything, this is kind of exactly what we would expect the perfect sound system to be, where we have a locomotive with a giant speaker that's able to reproduce a full range, low frequency as well as high frequencies around. But unfortunately, that won't clear our tunnels, and so we have to kind of compromise. And so that's where hopefully we've given you a lot of information here today that will give you some ideas on some things to try out and how to get the good sound out of your models. So some last things here as we're going to close up and open it up to questions and answers here in just a minute. We've been doing a weekly video series on our YouTube channel where you can watch and get a lot of great tips and hints and things like this that you can see, and they're short little 3 to 5 minute videos about features and things like that. So be sure to check that out, like and subscribe to that to make sure you get notifications that when we post new videos. Also, our steam and diesel users guides that we have posted, as well as our electric decoder and our Tsunami2 product line that you can find on our website, are very helpful. Will help explain how to use the equalizer, how to set the volumes and things like that. And use your ears. Let yourself listen to it and pick how those sound right to you. We can give you guidelines, but my ears may sound different than your ears, and so you're going to get some variation there. So trust yourself. As we talked about in our last webinar, you can change CVs all day long. You're not going to break the decoder. So try it out and play with different things and use our users guides as a guide. Other things we have at SoundTraxx.com, there's a document called the Sound Primer, which will kind of give you some documentation of a lot of the things that we've talked about today. The last thing here I'm going to show off is our next webinar will be scheduled for March 21st, again at 11 a.m. Mountain Time. This time we're going to go into some nuts and bolts. We're going to talk about programming CVs. We're going to cover some DCC myths, some things that are out there that are beliefs that may be inaccurate, and we'll cover some of those in detail and some troubles that you can run into. How to reset your decoder if you do get some weird behavior, and more. So we'll get that link up posted soon so you can register.